Well, welcome to the show. In part one, we did 10 minutes primarily looking at the expense of arc fault breakers on an upgrade, and we wanted to look at it in terms of the per circuit cost, basically of where they are. So that was that bit. Now I want to look at the code, what the code specifically says, and by the code I mean the NFPA 70 or the NEC 2020 edition, which is the latest one out and available. The state of Tennessee, if you're in the state of Tennessee, the fire marshal's office, who is charged primarily through the legislature for the enforcement of the building codes and electric codes, that sort of thing, has historically taken the latest code as the kind of the last word. In other words, if we're going through a developmental phase and arc faults are continuing to change with like every edition that comes out with a little bit of clarification, a little bit of change, all the time they're getting more and more narrowed down, that we can look at the newest code as more basically the final word, because we're trimming down the past controversies and we're getting to what we really want it to mean. So if there's any ambiguities in the previous editions, we normally will look at the latest as having clarified, being the latest and the greatest. That's where we are. So we're going to look at the NFPA 70, the NEC National Electric Code. And we're going to start with the definitions, because that's where most people mess up when they read a law or rule or code or something. They're reading it with their own common tongue, common defined words, and so they can get a different meaning than what we have if somebody's in the industry dealing with it and they have that knowledge that that's not what that word actually means. Okay, not in this context because it's written into a code or a law or rule. It means something different because it is defined as a difference. So there we are. So we're going to look at that. And one of the first places I want to look at is the definition specifically of what an arc fault is, because that was one of our two breakers. Now we'll have it right here, and it says that a arc fault circuit interrupter, a device intended to provide protection from the effects of an arc fault by recognizing the characteristic unique to arcing and by functioning to de-energize the circuit when an arc fault is detected. And that is great. But the problem why a lot of us are not big fans of arc fault is because every time you flip a light switch off, if it's got current going through it, if it's running a load, it's going to arc. Now, is that enough to do a false trip of a breaker? Ceiling fans, anything with a motor on it that has brushes, that actually has actual brushes, they arc every time it breaks contact, goes to a different set of loops in the armature or the rotor, either which way. It's going to arc as it switches the magnets in and out, and that can cause a lot of nuisance tripping. Now, from a code or safety enforcement perspective, we don't want to have nuisances where we annoy people to the point they defeat the device. A most common thing I can think of to explain to is like a smoke detector. How many times do we find out somebody had a fire and it was a fatal because they had a smoke detector and the darn thing kept going off, so the people just took it out and defeated it? Well, that's not what we want. We want to improve things, not to make things worse. And unfortunately, arc faults, this is just my personal opinion, no reflection on anything else in the entire world or anybody, I think we've gone a little bit overboard with arc faults. I don't have a problem with a common receptacle that we're plugging and unplugging many different things, and we're loosening up that receptacle, and it creates an arcing situation. That's not a big problem for me. For permanently connected devices, I'm a little bit more iffy on. And for things such as light circuits where we have just a light switch, we're going to expect some level of arc on a fairly regular basis, and hopefully our electronic breakers are smart enough not to trip off of that a little bit. We can have loose wiring on any circuitry in the house, and arc faults are not required on every circuit in the house. So if we're trying to capture them, we're ignoring quite a bit to begin with. So I'm just not real convinced of the necessity for arc faults. Now, there's a difference between an arc fault and a ground fault. Let's look here at the definition. A ground fault interrupter, a device intended for the protection of personnel that functions to de-energize the circuit or portion thereof within an established period of time when a ground fault current exceeds the values established for a Class A device. Okay, so what does that mean? The first thing I notice right off the bat is ground faults are the stated purposes is for us to protect us, not our buildings, not our property, not our cars or our boats or anything like that, but to protect people. And where do we find ground faults? In a home, we find the requirements are usually around water, where we have a normal functioning circuit of some sort, but the appearance of water with minerals in it can provide a path that maybe goes through us to the water to ground, and it can cause a serious problem to us as occupants and people. Whereas an arc fault is not really that strongly coupled with life safety, is it? It's more in life safety as we're trying to stop a house fire from coming on. Okay, so we're going to look at what the code says. And again, let's get back to definitions. I have some on some notes here that I'm going to read here in a little notepad. We'll read some of these definitions because when we go in to read what arc fault, the need where we have to put them into code according to the 2020 NEC is going to use some terms, and it'll help us make sense of it, what we're reading when we're reading it, because most of us are just amateurs. I'm not a professional, and I don't pretend to be. But let's look and see what it says, okay? Let's go back to the NEC. Let's go back all the way to the front to table of contents, definitions, and let's start with what an appliance is. I think it's on this first page here. It's a piece of utilization equipment, generally other than industrial, that is normally built in standard sizes and types and is installed or connected as a unit to perform one or more functions such as clothes washing, air conditioning, food mixing, deep frying, like an oven and stove, these type of things. They're normally built in certain sizes. It uses power. It's built in certain sizes and standard. It's a standard piece of equipment, basically. A standard appliance is what we're getting at. Now let's look at what a device is. It's over here on page 37. We want to look at what a device is. A unit of an electrical system other than a conductor, other than the wire, that carries or controls electric energy as its principal function. And I want to go there. You'll notice it says principal function. It's not the wire, but it's something in the system whose job is principally to conduct or control power. That's what a device is. It's not just anything in the world. It's specific in the electric code as being something whose principal purpose, right here, right there, whose principal function is to carry or control electric energy other than the wire itself. Okay, now let's look at what a luminaire is. It's over here on this 41 page, two more pages over. A luminaire, a complete lighting unit consisting of a light source, such as a lamp or lamps, together with the parts, designed to position the light source and connect it to a power supply. It may also include parts to protect the light source or ballast or to distribute the light. A lamp holder itself is not a luminaire. Okay, so that's an important thing. We know what a light is, a luminaire is, as the code will refer to it. Well, let's look at outlet. LMNO is on the same page. A point on a wiring system. Okay, a point on a wiring system which current is taken to supply utilization equipment. And we read that phrase, utilization equipment, when we were looking at what an appliance is. An appliance is a utilization equipment, but it's a specific type of utilization equipment that is built in standard sizes and that sort of thing. We've looked at that. So let's go back to the code and look at our next definition. Power outlet, 42. Now you might read across this as well, but it means something completely different. You might think the thing that you plug your hairdryer in is a power outlet, but it's not according to the code. Let's read what it is. It's an enclosed assembly that may include a receptacle, circuit breakers, fuse holders, fuse switches, buses, watt-hour meters, mounting means intended to supply and control power to a mobile home, recreational vehicle, park trailers, or boats, or to serve as a means for distributing power requirement to operate mobile or temporary installed equipment. So, according to the code, this is the reason I do this. According to the code, a power outlet is not a receptacle. It's not the thing you might think about. And that's one of the reasons I want to read that to you. Let's go back to the code. We do see that we have a receptacle outlet. Here we have receptacle and we have receptacle outlet. Receptacle is a contact device installed at the outlet for the connection of and its attachment plug for the direct connection of electrical utilization equipment. We got that word again, utilization equipment, designed to mate with the corresponding contact device. A single receptacle is a single contact device with no other contact devices on the same yoke or strap. Multiple receptacle is two or more contact devices on the same receptacle strap. Okay. You've seen like one round receptacle? That's a receptacle. When you see what we see on the wall normally that's got the two smiley faces, the one long eye, one short eye, that's a duplex receptacle. It has two receptacles. But they are outlets. Why? Because they take power off of the system. And it mentioned also utilization equipment. So your hairdryer is a piece of utilization equipment because it uses power, but it's not an appliance because it's not necessarily built in standard unit sizes other than industrial. So these definitions are very important when we go look at what an arc fault, where an arc fault is required. I think I only have like one more, which would be utilization equipment itself. Let's go over to the U. So there we have what the definition is: electrical equipment that utilizes electrical energy for electronic, electromechanical, chemical, heating, lighting, or similar purpose. That is utilization equipment. So that's pretty well met yet. So what do you say we go look a little bit at the ground fault and the arc fault parts in the code where they're brought up over in the branch circuits, because I want to look at those definitions a little bit. We've looked at definitions. Now we want to see how they fit into the requirements. So follow me over there if you will. Okay, I have loaded up the ground fault, which is right here. That is Article 210.8. Ground fault circuit interrupter protection for personnel. And I just want to hammer that home a little bit, that ground faults are for protecting people, whereas arc faults are more roundabout to protect people by helping not start a fire and the fire not hurt the people. So it's a little different than hurting by electricity versus hurting by some other type of second and third degree faults here. Ground fault interrupter circuit or protection for personnel shall be provided according to 210.8A through F. So that's going to tell us where we got to have them. Let's roll right up. A is going to be dwelling units, and that's primarily what we're going to talk about. Okay, I can read through this. All 125 through 250 volt receptacles, that would be a 2-pole receptacle, installed in the locations of 210.8A 1 through 11 shall be supplied with a branch circuit 150 volts left to ground, because a 250 volt or 240 is going to be two hot legs. Each one of them is less than 150 volts to ground to protect people. Right there, it just says right there, for personnel. Where you got to have them? Bathrooms, garages, outdoors. Why? Because we're going to have water and stuff outdoors probably. Rain happens. We have some exceptions here. Crawl spaces. Why? Because most of the time we have dirt under houses, and that can connect us to earth, between the earth and it to ground. Basements, they often are damp or whatever. It talks about kitchens, sinks, bathhouses, boathouses, bathtubs, laundry areas. Okay, so we should have, I think, one more here somewhere. 11. Yes, indoor damp and wet locations, because we had 11 parts. So we know that ground faults are associated with a risk of water, us getting connected to the ground through us, because we have minerals in our bodies just like most water does if it's not distilled or RO'd. So let's look at where arc faults are going to be used. Okay, arc faults are going to be over there in 210.12. Let's see if we can find 210.10, 210.12. There we are. Arc fault circuit interrupter protection. Arc fault circuit interrupter protection shall be provided as required in 210.12A, and then we're going to just talk about these units right here, dwelling units, because we're concentrating on residential. Let's read what it says, okay? Because sometimes even inspectors get this wrong and they misinterpret. Dwelling units. A, all 120 volt single phase 15 and 20 ampere branch circuits supplying outlets or devices installed in dwelling unit kitchens, family rooms, dining rooms, living rooms, parlors, libraries, dens, bedrooms, sunrooms, recreation rooms, closets, hallways, laundry areas, or similar rooms or areas shall be protected by any of the means. So when we look at that list of where they're required, you notice where they're not required? Outdoors. They're not required. Did you see garages in there? Or boat houses? Or things of this nature? No, it's pretty well much, when we look back at the code, it's living spaces where people are all single breaker, single pole, 120 volt circuits, 20 amps or less. Let's go back and look at that again. Okay, right there. 120 single phase 15 and 20 ampere breaker circuits in these living areas, and they talk about, and it gives you the opportunities, the different ways that we can comply with that right here. So what does it mean? Well, first of all, a 25 amp breaker or above, actually above 20, and I think 25 is the lowest above that, and it may also be fused if you have a specific fuse element that's less than that. If it's above 20 amps, you don't have to put an arc fault breaker. Now, do circuits that are 25 amps or 30 amps, do they ever arc? Well, of course they do. So to me, to be so all fired important that we have to have these we have to have these expensive breakers, we're still only going to do them on the single pole circuits of basically the receptacle connected type of outlet. We're looking at just that. It's just plug-ins is the only place we're going to put them. However, that's not actually that's not really all it says. So what's it talk about? If you have a 30 amp circuit or a dual pole, you could have a 15 amp circuit that's 220 volt, as long as it's a common tie or a 220 volt, so it has two hot legs. It doesn't have to have an arc fault on it. You don't have to have them everywhere in the building, okay? Just your living areas. Now, it is a little bit hinky in certain ways because like things like a dishwasher. A dishwasher often is a 15 amp circuit. You might find one if you have a real high booster element on it. It might actually be a 20 amp circuit. It's normally direct connected to your wire, to the conductor. Normally you go from the breaker panel, the breaker, the conductor terminates inside the appliance. We read what an appliance is, right? So it ends up in the appliance. Does this say we need an arc fault then for a dishwasher? Let's go back and read this, because we do know that we know about dual function breakers. This says right here, all right, all 120 volt single phase 15 and 20 ampere branch circuits, which a dishwasher would be, supplying outlets or devices. Well, let's go back to that definition of what an appliance is. It's a piece of utilization equipment, okay? It didn't say go into utilization equipment, did it? It said outlets or devices. Well, if we go to devices, a device is a unit of an electrical system other than the conductor that carries or controls electric energy as its principal function. What is the principal function of a clothes washing machine or a clothes dryer? Is it to conduct power or to dry or wash clothes? What about dishwasher? Its principal function is to wash dishes, just like the clothes dryer to dry clothes, whatever. It is not a device, okay? Normally when we talk about the device, we're looking at something like a switch or a breaker outlet, a receptacle outlet type thing, something of this nature, not an appliance. So it doesn't apply to devices. Well, let's go back and look at that outlet version again. What is an outlet? An outlet is the point on the wiring system at which the current is taken to supply utilization equipment. Well, in the case of a dishwasher, there is no outlet. It terminates directly in the appliance. So it doesn't really feed that. Let's go back to 210, arc faults. It says current circuits, branch circuits supplying outlets or devices. So we wouldn't necessarily have to put an arc fault breaker on a dishwasher. And it kind of makes sense when you think about it. We're not unplugging or plugging or unplugging or unplugging a dishwasher. It's permanently wired in. They will make you, I'll bet you $1 to a donut if you're in Tennessee, if you have a microwave, that they will make you put an arc fault on a microwave. Although a microwave is plugged in, it doesn't get plugged and unplugged and plugged and unplugged and plugged and unplugged and plugged and to where it works, the contacts inside of the receptacle lose. It gets plugged in once and stays plugged in. But it is an outlet because we saw that a receptacle is a power outlet. It is a device, and it is also a power outlet because it is designed for taking power out of the system. So according to the code, if it has a receptacle and it's a plug-in receptacle cord connected, it has to have an arc fault breaker. That's what it seems to read to me. You make your own mind up. We're not professionals. We're just enjoying ourselves on a video. Okay, so there where we are. Well, we do get into a requirement for a dishwasher, where if we go back to ground fault, we have right here, ground fault circuit interrupter protection for personnel. And if you remember, we had 11 things we had to have in a dwelling unit where we had to have them. That's not every place that we have to have them, but in a dwelling unit, it's saying specifically the bathroom, the garages, outdoor, crawl spaces, basement, kitchens, sinks, boathouses, bathtubs or shower stalls, laundry areas. And then it talks about other than dwelling units. And I think we have one more section that we want to look at. Comes right up here. Rooftops, outdoors, blah, blah, blah. Crawl space, lighting outlets, specific appliances. And that's where we hit our dishwasher. Specific appliances. Unless GFCI protection is provided in accordance with 422.5B3 through B5, the outlet supplying the appliances specified in 422.5A shall be GFCI protected in accordance with 422B1 or B2. So what does all that mean? Well, let's go look at 422, which is going to be appliances. Let me slide up, get that loaded for us, and go back to the page of the articles. And we were talking about 422.5, and it was talking about the ground fault. We will find in here a specific piece of information that tells us we have to put dishwashers on ground faults if the dishwasher is not therefore capable of protecting us humans from electrical shock through fault to ground. Automotive vacuum machines, drinking water coolers and bottles, cord and plug connected high pressure spraying washing machines, tire inflation vending machines, sump pumps. Gosh darn it, right there it is. It says dishwashers. So in the branch circuit protection, we're not required to have it. But according to this, the appliance, if the appliance happens to be a dishwasher, it does have to have it if it's not already protected internal to the dishwasher. And it does kind of give us a hint what they're trying to solve here. The informational note, which is not necessarily code unless we see it adopted, that all informational notes are adopted as well. This counts for nothing except perhaps an argument. It says 210.8, where we were in branch circuits, specifies the requirements for GFCI protection for branch circuit outlets where the covered location warrants such protection. In other words, if your dishwasher is not apt to give you electrical shock, it's telling you that how we get to here to dishwashers will be protected under appliances. However, it doesn't have an outlet. It's not plugged in. It terminates directly in the appliance, the piece of utilization equipment. Now, you can try to argue this, that your UL listed dishwasher is safe and doesn't need a GFCI, but you'll probably lose. And to be quite honest, at the cost of a reinspection being about what the breaker is, it won't make any sense really to argue the point. You might as well put the $40 breaker in and be safe, because you know it's going to fault if we get a fault to ground, and it does it anyway. However, if you look strictly at the definitions, the branch circuit itself does not require it, and your dishwasher, if it's sufficiently protected, doesn't have to have it. And what are we having ground fault protection for anyway? People. So if you're not likely, according to this personal note, this informational note, if the circuit warrants it, you have to put it in there. So they're going to require you to put a ground fault breaker in on dishwashers now, even though it has no outlet per se. It is a breaker panel, a device, a conductor, and an appliance. There is no outlet there. There is no outlet. It terminates directly into the listed piece of equipment. So that would be something you could argue if you just want to argue, but I'll bet you $1 to a donut you'll lose that. And, you know, again, the cost of an inspection, a permit in Tennessee, electrical permit, is going to run you probably about what it's going to take to buy that breaker. And then, of course, cost you the time to go back and have to reschedule for the reinspection after you put the breaker in that they just told you had to put it in anyway, comes in. So what is the difference between arc faults and GFCI? GFCIs are to protect people. Arc faults, in a roundabout way, do. If we can stop having a fire on the circuit, then that's great. And the limit that we run into is that it's really kind of illogical where the code is requiring them to be, but you're not going to argue with City Hall. They're going to force them on you where they force them on you. Where do you not have to have them? Garages, outside, they don't have to have them everywhere. Anything that is above 20 amps or anything that is dual pole. So you don't have to have. So if they're so important that we have to have them, oh, I forgot to show you something. This is very important. You want to see this. Let's go back to the code. So here we are, back at arc fault, right where we are, arc fault dwelling units. And they tell us how and where we have to have them. I want you to look right here. I mean, remember, these things are so important that we have to pay $40 and $50 a piece for each breaker, because we just have to have them because it's just that important. And it says arc fault protection shall not be required for an individual branch circuit supplying what? A microwave or dishwasher? No. Anything? Nope. Fire alarm. Why? If they're that important, why don't we have to put them in a fire alarm? And it does go further to say that it has to be installed in a metal raceway and a metal auxiliary gutter, steel armored cable type MC or AC type of cable. Yes, so they're that important we have to pay 6 times the price for a breaker, except we're not going to make you put them on double poles. We're not going to make them put them on anything over 20 amps, and we're not going to make them put them on outside or in a garage. But yet we can still have arcs there as well. And so to me, the potential of having a fire goes up with the amperage of current draw that we draw, but we're not only going to put them on 15 and 20 amp circuits, single pole. Okay? And we're not going to put them on fire alarms. And my inspector tells us that we don't have to put them on refrigerators, that we've specifically exempted a refrigerator if it's on its own circuit. Why don't we exempt microwaves? I don't know. Again, to me, a worn out receptacle is liable to arc a little bit more than a fresh tight one. But if we're not going to put them everywhere on all the other devices anyway, all we're doing is we're saving some nuisance tripping. So that's what the code says, where you put them. It's not everywhere. I've heard some people say, well, you got to put them on every circuit. You don't have to put them on every circuit. That's not true. And some circuits may have ground fault protection. And that to me I like, because it's protecting me and you from getting shocked with providing that accidental path to ground because there's some water or something around us. So that's pretty good. So we've run quite a bit of time. I didn't really intend to go quite this long, but it's really kind of it's just one of those things you have to look through to see what's going on. So we'll see you in the next episode. I hope this didn't ramble too much, but it's not as bad as some people would say as far as the extra cost goes. When you upgrade something, you don't have to put them everywhere. You need to know where they are. And there is a difference between them. I want you to understand the difference between ground fault and arc fault protection, and then realize where they are. So I hope this helps. And remember, this was the 220 electrical code. It may not be adopted in your area at the time you watch this, but again, historically, if there's been a little bit of ambiguity with arc faults, and they tend to change every single code that comes out, they tend to change exactly what it says. You can generally go to the newest version and use it for gospel as being the latest and greatest, the most discussed version on the particular subject, and they'll normally take that as a position. On some of these things, it just isn't worth the effort to fight them, and the people know that. So you might as well buy your breakers and put them in where you can, but you may not have to change them out. Remember, in modernization, did I show you that? No, I didn't show you that. In modernization on arc faults, let's go back to the code. Yes, it's the D part right there. Branch circuit extensions or modifications. Dwelling units, dormitory units, guest rooms, and guest suites. Where branch circuit wiring for any other areas specified in A, B, or C. That's these up this way. Dormitory, homes, and residential and non-residential. It gets in there. It says, is modified, replaced, or extended, the branch circuit shall be protected by one of the following. Any of the means described basically above, A1 through A6, or you can have a listed branch circuit outlet. Like if you want to think about like the GFCI outlets, you can put an outlet if it's the very first one, you can do it that way, or you can put a breaker in. I will point out here, notice this, there is an exemption to it to a certain extent. Exception, arc fault circuit interrupter protection shall not be required where the extension of the existing branch circuit conductors is not more than 6 feet, and that does not include any additional outlets, we read that definition, or devices other than splicing devices. This measurement shall include the conductors inside of the enclosure cabinet, shall not include inside the cabinet or enclosure or the junction box. They put that in primarily for when people put in new panels. If they do a panel upgrade, they're saying you don't have to upgrade all the breakers. And a lot of times you're going to find if somebody comes out to your house and they tell you have a new panel, the first thing they're going to do is stick you with it and tell you they got to have arc faults everywhere. And if they work off a percentage, you might find out that they're upgrading things. And you don't have to upgrade them according to the 2020 National Electric Code. And the previous editions had that in there too. If you just put in a new panel adjacent to the old one and you have to wire it and splice over to the other panel because the box is different and it's part of a listed enclosure, you don't have to upgrade your breakers. Is that an important thing to tack on at the end of a very long video? I hope so. Anyway, we appreciate you watching. I hope this was helpful to you. And remember, we're not experts.